Okay, guys, here we go. Lesson 7.2, we're going to talk about the division properties of exponents. Okay, so we're going to do some examples with division and then come up with the rule underneath. And we'll do that for both quotient of powers and power of a quotient. I know that sounds like they're the same one, just the words are out of order, but it is actually different. So first, let's say we have the problem 2/7 divided by 2⁴. So first thing you got to note is that the bases are the same. Okay, so I'm going to draw little arrows there. Note, same, same, okay? And when I expand out to the 7th, I get to 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7 of them, over 2 times 2 times 2 times 2, 4 of them. But something I notice is that when I divide 2 by 2, I get 1, and 2 divided by 2 is 1, and 2 divided by 2 is 1, and 2 divided by 2 is 1. So when I finish, all I'm left with is 3 2's. So, excuse me, I don't really want to sit here and draw out, expand out every power so that I can see what I can cross off and so on and so forth. So I want to see if there is a faster way of doing this. So I'm looking at my bases 2, and I'm looking at my exponents 7 and 4, and is there a way for me to get to 3 without doing all this other work? And the answer is light bulb time. Okay, the answer is yes. That was my sad attempt at a light bulb. Yeah, that's it. Light bulb. Okay, so what you notice is if I take my base of 2 and I take the exponents, 7 take away 4, that's going to give me 2 cubed. So this is going to be the quotient of powers property. Quotient, answer to the division problem, of powers property. So I'm dividing powers. So it says when dividing powers with the same base, we are going to subtract the exponents. Now, there's only one way to subtract these exponents, and that's going to be top down, or in other words, numerator minus denominator on the exponents, okay? All right, so algebraically, if we have a problem where we have a to the mth power, and we're going to divide it by a to the nth power, that's going to end up equaling the base once, and then we're going to have m minus n for to get to the new exponent, okay? So next property, I think I can squish it onto here. We've got 3 to the 4th power, or 3/4, excuse me, and we want to raise it to the 4th power. So now this one doesn't have any variables, but we're going to apply the rule to it. So remember from before, I can expand this out as 3/4 times 3/4 times 3/4, okay? And that's going to give me 4 3s, so 3 to the 4th power, and 4 4s, or 4 to the 4th power. Now, is there a way of doing this a different way? And the answer is yes, if you think back to what we did before. If you don't see an exponent on a base, then it has an exponent of 1. So what that would give us, so I'm going to draw this out here or there, I would have 1 on each of them, and then I would multiply by the power on the outside. So remember, the power to a power, this is exactly what we're doing here, and then we would end up with 3 to the 4th power over 4 divided by 4 to the 4th power. Okay, now you might say, well, what does that have to do with anything? Well, you're going to see in a minute that we're going to be doing kind of a combination of problems. Okay, so let me show you this guy. So I guess, basically understand that when I take a fraction to a power, a fraction is fancy, it's a quotient, to a power, every part of that fraction gets taken to that power. So let's say I have, with variables, x to the 8th divided by x to the 5th. Okay. So then that would give me, if I use this second idea I had, we have x to the 8th over x to the 5th, and then we're going to multiply. Oops, I forgot to add that power. Sorry, that would make this a better problem. Let's square that whole quotient. So then we're going to have 8 times 2, and we're going to have 5 times 2. So we get x to the 16th over x to the 10th. Now, the reality is there's more I can do, right? Because they both have the same base, where in the example I had before, the bases were different. One was a 3, one was a 4. So then I'm going to use the rule, the quotient of powers property, okay? So then that's going to take me to x, and then we're going to take numerator minus denominator, and that's going to give me x to the 6th power. Okay, now there's a secondary way of doing this one, and that's what if we do the quotient of powers first and then raise to the power. Okay, so let's go back to here. So what we could do is not start with 8, start with the base of x, and then we would take the 8 minus 5. Oh, here I go again. Gosh, what is my problem with this squared over here? I'm going to keep that over here too. So that's going to give me 8 cubed, and then I'm going to raise that to the 2nd power, and then I'm going to employ the power to a power from 7, 1, and I get 3 times 2, and I get x to the 6. So that's a different way of doing this problem. So let's write down this quotient, or this property. So this is called the power of a quotient. So we're raising a quotient to a power. Power of a quotient property. And that says when raising a quotient, and again, I'm going to write here fraction, to a power, we're going to multiply exponents in the numerator and in the denominator by the outside exponent. So by that power outside. I know I just wrote it outside like it's 2 words, but it's 1. Okay, so let me show you what that looks like. Algebraically, let's say we have a to the mth power, and we want to divide it by a to the nth power. So here's my quotient. But then I want to raise the whole thing to the t power. So what we're going to do is we're going to take that numerator and we're going to multiply the numerator's exponent by the outside exponent. And then we're going to take, in the denominator, we're going to do the same thing with the denominator's exponent times the outside exponent. Okay? And that's how I would get my answer. All right, so I'm going to go to the next screen, and we're going to do a couple of examples, and we'll call it quits for today. So the directions are going to just say simplify. Okay, and then I need to give you a little assume. So assume no denominator equals 0. And why do we have to assume that? Because if I have a denominator that equals 0, then I'm dividing by 0, which is a mathematical impossibility. Undefined. Remember, that's the same idea. So we've got g cubed h to the 5th. And we've got g, and then we've got h squared. Okay. So now what we're going to do is split apart using the rules, and this is going to be that quotient of powers. So I'm going to separate the g's from the h's. And I notice on the bottom the g doesn't have an exponent, which means it is a 1. So then I'm going to do numerator minus denominator. So that's my g's is 3 take away 1. And numerator take away denominator on my h's, okay? And then we simplify. So that's what I'm doing off to the right is what I call a brain step, So then 3 take away 1 is, oh, I wrote that. No, I did it fine. I did g squared, and then 5 take away 2 is 3. So notice what happens. I no longer have a fraction. Okay, now, in the next set of notes, we'll talk about, well, what if you do the subtraction and you get a negative exponent? So that will come up at another time. So we've got k to the 7th, m to the 10th, p divided by k to the 5th, m cubed, p. Okay, so remember with our p's, they actually have an exponent of 1. So in my head, this is what I'm going to do. I'm going to take the k's, and I'm going to subtract the exponents. Top, take away bottom. Then I'm going to have my m's. And we're going to do 10, take away 3, top, take away bottom. And then the p's, we're going to do 1, take away 1. Okay, so that's what I'm doing in my head. And what I end up with is k squared m to the 7th p to the 0. Now, guess what? P to the 0. So if I divide something by itself, I get 1. That is the same thing, dividing a number by itself, as getting p to the 0 equals 1. So this guy right here, whoop, equals 1. So my final answer is k squared m to the 7th. Okay? All right, so let's go the other direction. Let's talk about the power of a quotient. property. Now, it may still entail the quotient of powers property, so we'll just have to see. So I've got the quantity 3x to the fourth divided by 4, and I want to raise that to the third power. Okay, so remember, anything that doesn't have a variable, doesn't have an exponent, has an exponent of 1. You just don't see it because it's kind of redundant, because if I have a 3, that means I have 1, 3. Got it? So on this one, I'm going to take my 3, and then I'm going to go ahead and do 1 times the outside number 3. And then I have my x, and I'm going to do 4 times the 3. Now, this one's interesting because I can't get rid of that 4 because I don't have a matching base on top. And so this guy is going to be 1 times 3. So that's what my head is kind of doing, is multiplying each of those coefficients, or each of those exponents, by 3. So what do I end up with? Let's see, I get 3 cubed x to the 12th over 4 cubed. Now, generally speaking, you are not going to leave your answers in exponential form. That means leaving it with exponents. So that says, if that's the case, which they would have to tell you to leave it in exponential form. If they don't say that, then you are going to expand out and solve. So 3 cubed is 3 times 3 times 3, so that's 9 times 3 is 27. And we still have x to the 12th. And then 4 cubed is 4 times 4, 4 cubed equals 4 times 4 times 4. So 16 times 4, I guess I didn't write out my answers. How rude is that? Go back and do that here. There we go. And we get a denominator of 64. 27 and 64 have nothing in common. I can't simplify, and I am done. All right, last example. So this one we've got 2y squared over 3z cubed. So I put that slash through my z because so it doesn't look like a 2. And then we're going to square the whole thing. So again, anything that doesn't have an exponent gets an exponent of 1. So my numbers don't have that. So what is my head doing on this problem? What am I thinking about? Well, I'm going to take the 2 and I'm going to do 1 times the power on the outside. So that's power of a quotient. We're going to use that rule from before. We're going to multiply. And then we get y, and that's going to be with an exponent of 2 times the outside 2. And then in the denominator, we're going to have 3, and it's going to be 1 times the 2. So everything is getting multiplied by that outside 2 in the exponents. And then we've got z, and we've got, let's do 3 times that outside 2. So that's what I'm doing in my head. And what does it produce? 2 squared y to the 4th over 3 squared z to the 6th. So then I have to figure out what those numbers are. I don't stop there because I can do more math. So remember, 2 squared is 2 times 2, or 4. So that allows me to write 4y to the 4th. And then we've got 3 squared, which again, 3 times 3 is 9. And so in the denominator, we're going to have 9z to the 6th. Now, the variables don't match, so there's nothing more I can do. And now I am done. And that's it. All right, we'll talk to you later, guys. Bye now.